Good morning, everyone, and welcome to week 3 of the robotics lectures. What we're going to do today is we're going to run a mission to land a rocket on the moon, or at least land a probe on the moon. I guess the probe is going to be a rocket. In any case, we're going to launch this thing, and the result is going to be landing a thing on the moon. This is going to be a partially automated mission, and this is in preparation for homework 3, where you are going to write a script that's going to do a complete automated mission where you're going to land something on the moon without it blowing up. So I can go ahead and start off and just run the launch script and keep talking. Run launch. So this rocket's going to go ahead and launch up into space. This is my launch script that is going to try to be a little bit clever with tilting. If you were at this past Thursday's live meeting or zoomed into it, you got to see this launch script be completely ineffectual running on my laptop. Here it's going to run a little bit more smoothly because this machine has the oomph to actually run Kerbal Space Program and record it. And probably also because I'm not running Zoom, nothing else is trying to bog this down. In fact, this machine is fast enough that I can actually run this launch time warped at double speed and go ahead and get this up into space pretty quickly. This is going to keep going, accelerating up until the apoapsis is at 100 kilometers, and at that point it's going to stop and we do the next step. Almost there. Alright, once it hits 100 kilometers, I'll go ahead and time warp back down. It created a maneuver node. We can see that right here. We have this green thing next to the nav ball that says that we are planning to do a maneuver that is going to change the velocity of the ship by 755 meters per second. If we look at the map view, we can see that our ship is moving along on this blue line. This is our trajectory. We're going to hit an apoapsis of 99.8 kilometers in about 2 minutes. That is where we're going to do the maneuver. This star is showing the maneuver node. And once we get there and do that maneuver, it's going to put us in this orbit, which is shown by this dotted orange line. The reason there's a white line there is because I already launched one of these Moonlander robots and got it into orbit. But that's okay, we're working with this one. So I'm going to go ahead and do a little bit more time acceleration to get us up to that maneuver node. So that warp to maneuver thing causes us to go to 1 minute before the maneuver node. And now this script that we're running that launches is going to attempt to execute this maneuver node at the appropriate time. Now that time is so it's estimating that it's going to take 16 seconds to do the burn. So it's actually going to start doing the burn 8 seconds before the node itself. So that will let it do half the burn before and half the burn after the maneuver node. Burning not on the maneuver node causes slightly different results when you're burning before it is giving you an error in one direction, burning after gives you an error in the other direction, and so if they're the same, they even out. So here we go, we're starting the burn at 8. You can see here the maneuver node is going down, our orbit is changing, the rocket ship is actually burning the engine. And this is going to go ahead and put us in pretty much the same orbit as the other rocket ship was already in. Now, our launch thing crashed. That's fine for the moment. We'll just kill that off because it left us here in space. Now that we're in space, I'm going to quick save. Sorry, I'm going to quick save, which is F5, because I'm probably going to mess this up and need to quick load. But the next step that we have to do for our moon mission is we have to get into lunar orbit. Now if we zoom out in the map view, we can see the moon here. That's the moon orbiting Kerbin. If we zoom out a little bit more, we can see that Kerbin actually has a second moon called Mun Mission, which is not the moon that we're going for this or for the homework. It is a little bit easier to get to Mun Mission because the gravity is lower. If we zoom out even more, we can see that Kerbin is just one of the planets in the system, and all of the planets are orbiting around this star over here, which is called the Sun or Kerbal, depending on your source. But we're just trying to get to the closest thing, which is the moon. So I'm going to set that as my target. It's going to show me this ascending and descending node, which are not things that I need to mess with right now because we are in the same plane as the moon approximately. And then what I want to do is I want to create a maneuver node, which is going to allow us to change from being in a circular orbit around Kerbin to being in a transfer orbit to the moon. Now, orbits in Kerbal Space Program follow Keplerian mechanics. And I'm going to have a little bit of a video on how the Keplerian model works in detail. Kepler was the guy who figured out how orbits basically worked. This was a little bit before Newton did all his stuff with physics. And his model is basically just that, or Kepler's model is basically just that all orbits are conic sections. Specifically, they're all, what's the word, ovals. Now I don't remember English. We have ellipses. It's elliptical orbits. So when we change our orbit, this is just changing the shape of this ellipse. And we're going to go ahead and get this set up correctly so that we're going to get an intercept with the moon here. And so if we just go ahead and set our apoapsis so that it's where the moon is now, that's not quite the right thing. Because as we drift to get to our apoapsis around our new orbit, the moon is also going to move. So we have to sort of predict where the moon's going to be in the future. And then we get this nice nice purple moon, which is showing us what the situation is going to be when we actually get our moon intercept. I want to try to adjust this so that we get a nice close encounter. 300 kilometers to the moon is fine, so that's going to be our maneuver. Now we're going to quick save again because I don't trust it. And then we're going to warp to that maneuver that we just set up. Now part of the challenge of the homework, the code to actually execute a maneuver node is actually in the tutorial, is some code that you can adapt to do it. That's what I'm using. But the trick of making a maneuver node is a little bit more complicated. You have an API to make a maneuver node that requests when in time, like how many seconds in the future you want to create the maneuver node along your orbit. And then in addition to that, you need to know how much you want to burn sort of as a vector. And you specify it as 3 things: prograde, how much do you want to burn forward, how much do you want to burn up, how much do you want to burn out away from the planet. Burning away from the planet isn't terribly useful. Usually you don't do that. But those are the 3 directions you could potentially burn. So you make a vector of all of those things. And then we're trying to do this burn. And then that'll create the maneuver node. Oh, we need to stage. 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 Oh, it looks like I'm now running this manually, but the trick is where to put the maneuver node, and you can't just sort of wiggle around the maneuver node graphically the way I did to find the thing. You have to actually sort of predict where the moon is going to be, predict where or then calculate where the opposite side of the thing is. where the opposite side of the orbit is, then calculate how long it's going to take you to get there, and then that's where to put the maneuver node. Calculating the speed that you need to do isn't that difficult. You just need to make it so that your new apoapsis is going to be at the same altitude as the moon is approximately, but the other stuff is a little harder. So now we have this pointing in the right direction. I'm going to take a quick break, but I'll be back. Alright, my headset was running out of batteries. I'm back. Let's go ahead and try to get this spaceship to end up in lunar orbit. To do that, we're going to go ahead and focus view on the moon, which is going to show us the sort of hyperbolic segment here of the orbit that is around the moon. So we have a segment of Kerbal orbit, which is an ellipse. Then we have this segment, which is either a ellipse or a hyperbola. I don't know. Looks kind of hyperbola-y. But here at periapsis of the moon, we want to do a burn to circularize, something like that. And that is sort of straightforward enough. We'll then just, I'm going to save. But after we save, I'm going to warp to this maneuver. Calculating this maneuver should be relatively simple, because you can use ETA : periapsis to figure out your time to periapsis, and then either do a calculation to figure out where your orbital velocity needs to be, or otherwise be clever to see what's going on. So this is sort of amusing. So the running the execute node script again, let's see if that works. So we have the blue line here, which is the first pass through lunar orbit. Then we have this orange line over here, which is where we're going to be if we don't do this burn and we go back into Kerbin orbit. And then this purple line is a segment of actually we hit the moon again, and that's where we're going to hit. But we're not going to, because we're going to execute this particular maneuver node in about 20 seconds. I'm not going to time accelerate. So once we're done with this maneuver to circularize, that's 180, 200 isn't that far off from being circular. The next thing that we're going to have to do is land this thing. And landing this thing, I have a landing script that I'm going to try out. I don't know if it's going to work, but generally I think about doing that in 2 steps. So here's our burn, we end up in a circular orbit, and then that worked nicely. So now what I want to do is I want to do another, I want to warp to here, because I want to land on the light side of the moon just for being able to see what we're doing. So I'm going to add a maneuver here, which is going to drop us. There's what looks vaguely like a bunch of clear spots here. We'll see if we end up on a cliff or in a crater and explode, but hopefully we won't. So I'm again going to save, and then we're going to warp to that maneuver, and then we're going to be ready to execute this node. So doing this as a single script would be pretty similar. We just have to have scripts to create the maneuvers, and then once we've created the maneuvers, we have to execute the nodes, and we probably also want auto time warp, because time warping here is pretty important, and if we don't have the script automatically time warp for us, either we have to be doing it manually, which is going to end up messing up the thing, because we're going to forget to, or fail to stop warping at the right time and such, or we can just do automatic time warping. Or sorry, if we don't do automatic time warping and don't time warp at all, then we have to wait for like the full day for the orbit to go from like Kerbin orbit to the moon. That transfer orbit segment takes like a day. Now it's only a Kerbin day, so it's only 6 hours, but that's still an awful long time to like leave your computer running waiting for it to do its thing. Alright, so here's our burn. And now we are in a suborbital trajectory, and we're going to impact on the moon if we don't do anything. Right now we're going 314 meters per second in orbit, well, not orbit, suborbital around the moon. That's going to result in us falling down and hitting. So I'm going to save. Saving is a good plan here. Alright, I guess we would land this thing. And it turns out that I don't have a working landing script, so we're just going to land this thing manually. Now, our strategy for landing this is going to be to take our flight engineer thing here and take this landing mode, because this gives us our suicide burn countdown. So that tells us, according to Kerbal Engineer, how long do we have before we need to start burning. And I'm going to start time warping to try to get the suicide burn countdown down a little bit further. Suicide burn altitude is 7.5. I'm going to switch to being able to see what I'm doing. Where'd the moon go? There it is. I'm going to use this thing to get the thing to point retrograde, so it's pointing so that if it fires the engine, it's going to slow down. And then we are going to want to start suicide burning at 7,500. So I'm going to time warp a little bit so that we get down to, I don't know, 50 kilometers. $80, $70, $60, $50. So we're currently going. It still thinks that we can suicide burn at 7,500. Kerbal Engineer is not always 100% accurate on that, but probably if I go down to twice that altitude, or around 15, we will be able to do a burn to slow down a little bit. And I'm going to go ahead and just start the burn, because I want to be going slower. So I'm going to burn here until we get the suicide burn altitude down to, well, 5,000 now. So now it says that we don't have to burn for another minute. Time warp a little bit more, waiting for the suicide burn countdown to go to like 20. And actually I'm going to start staging. So here is my lander. I'm going to extend my landing legs. That booster that I dropped is going to start exploding. Some mod is giving me a target here that shows where we're going to land. I don't know how much I trust it. Burn. Alright, so you can see the suicide burn number is going up as we slow down. Gonna wait for this to go back to 5. And then burn to half my velocity. Wait for it to go to 5. Burn to half my velocity. Wait for it to go to 5. Burn. And now we're slow enough that we can just start to do this plan where we're gonna burn a little bit. Oh, I went a little too fast and went back up. So this strategy that I'm using of wait for the suicide burn countdown to get low and then burn is an okay strategy for manually landing, but not necessarily the optimal strategy, because you screw up and then you're going that way. So I'm going to do a little bit of but yeah, a script doesn't necessarily want to use exactly the same strategies as a person. Alright, we landed. The actual impact was well over 1 meter per second. It was like 3 or 4 meters per second. But that was still an okay landing, and now we have our spaceship on the ground on the moon. So that's my test mission. Would have been better with a landing script, but that general process of launch, transfer, land are the steps that you're going to need to automate for the homework. Good luck and have fun.